All right, so we have some more hypothesis testing in Chapter 10, Section 3. Um, with Section 3, we're dealing with means, though. So in Section 2, we were dealing with proportions. Section 3, we're dealing with means. So if you want to compute a test statistic, um, again, we're going to use StatCrunch to do this, but they've already given us what our null hypothesis is and alternative hypothesis. We know our sample size is 20, and it's known to be normally distributed. So if the sample mean was that, with a sample standard deviation of this, compute the test statistic. So if we go into StatCrunch, we're going to type in this information. So if we do t-stats, so I think in Section 2 we were in proportion stats. Now we're dealing with mean, so we're going to be in t-stats. One sample with summary. They told us that the sample mean was 18.5, standard deviation was 3.8, and I believe our sample size was 20. And I recall that the mean is 20 and they thought it would be greater than 20. Less than 20, sorry. So again, let's look at the question. So here's our null hypothesis. Mean is 20. Alternative is that it's less than 20. And we're just computing a test statistic. So we have all our information and we hit compute. Well, this is our p-value we talked about last time. If the p is low, the hoe gotta go. The null hypothesis. But here's my test statistic. It's right next to my p-value. So negative 1.77. If I'm going to 2 decimal places, will give me my test statistic. That's something that we could use to compare it to our critical value. On this one, are we one-tailed, two-tailed, or three-tailed? No. Is our tail to the left? Is it to the right? Or is it 2 tails? So since we are a less than alternative hypothesis, we will be a left-tailed. The p-value, so ours is 0.0468, so that is, let's see, looks like it'd be in between there. And since our p-value is less than our alpha, so our p is low, which means the null hypothesis, the hoe gotta go, we will reject the null hypothesis since the p-value is less than alpha. And again, so that's what we're doing. We're just saying, hey, I don't think the mean is 20 anymore. I actually think it's less than 20. Now, I could be wrong. If I rejected, and I shouldn't have, I think we should recall that that's a type 1 error from Section 1. Another one to look at, question number 8. First, you have to determine if it's a normal distribution to make sure. So here's we're talking about the diameter of golf balls. And there's a certain diameter that golf balls have to be. Otherwise, maybe too big a target to hit. There'd be some type of rule violation. We all experienced that with Inflategate with football last year. But if we see that we're looking at something that falls within our probability plot, we can say, we're close enough to a normal distribution. So we'd say yes. Now, if we're looking at this, do the golf balls conform to the standards? So our null is that the mean is equal to that. Our alternative, do we think it's less than, greater than, or not equal to? Well, there's nothing that really states less than or greater than. So if there's nothing that states that, we would have to say that it's not equal to. Would be our alternative hypothesis. Find the test statistic. So this one they give us data, right? So let's just take this data and open it in StatCrunch. So we don't have to compute the mean or the standard deviation, because when we go to our t-stats, we're going to say with data. There's our data. Our mean is 1.68, and we put that it's not 1.68. So it finds our test statistic and it finds our p-value. So let's look at that. Our test statistic to 2 decimal places is 0.83. Our p-value is pretty big. Basically saying that there's a 42% chance that if we had another sample size similar to what we have, we would get a mean of 1.681. So we're pretty close to the 1.68. Let's get 3 decimal places in there. And now lastly, what are we going to do? Are we going to reject or fail to reject? So there is not sufficient evidence to conclude that the golf balls do not conform, or there is sufficient evidence. So when we see there is sufficient evidence, usually that means we are going to reject. There is not sufficient evidence to conclude that the golf balls do not conform to the association standards. So since this is a fail to reject, we have not sufficient evidence.